This is true science. Here, look at this, Rahu, Wikipedia. Let's have a look at this one. In Hindu tradition, Rahu is the severed head of an asura called Svarbanu and swallows the sun during eclipses. He is depicted in art as a serpent with no body, riding a chariot drawn by 8 black horses. Rahu is one of the Navagraha. Yeah, Navagraha. Yeah. Nava means 9, or I think, or it might mean boat, navigate. But it also has to do with 9, and it means the 9 planets. And those include the 7 visible planets and the 2 nodes.
Nice.
Right?
Yeah. Nice.
Makes sense. Yeah.
Sure makes sense to me. I love it. Yeah. And
here,
go ahead.
Response to, and here it is. You see, there's a tradition that the head was split into 7 pieces. This is what I'm talking about, the 7 discs.
Yes.
It is said to be split into 7 pieces, although it might be less, but it does make sense because there are discs scattered all over this point, and this is why most people will discount Rahu, because Rahu is not always on the same degree, okay, as the sun and the moon, but those 4 degrees, there is within that 4 degrees is where all the eclipses happen. This is the point. So, it might be that one of it's only 2 or 3 of the discs that have this effect to totally block.
Surely, absolutely.
And those nodes are somewhere associated with the firmament, and scientists know exactly the degree and the declination, especially declination of the nodes, and hence they can predict when a total eclipse is going to happen. It's trickery. They're claiming that they can do this with a rotating, orbiting, and all of these various motions of the heliocentric model. It's impossible. You cannot predict eclipses with this model. They know it.
Absolutely. And what I was going to say is, because there's nothing new under the sun, it's a system, because there's only full moons at the southern descending node. There's only lunar eclipses on a full moon, and there's only solar eclipses on a new moon. And that's case closed. It's just, it's only happens at those times. It's like a system. Nothing new under the sun.
Yeah. So the prediction I'd like to make is that what are people going to see? Well, there's going to be a lot of cameras out. I know that. Everybody's excited about this particular eclipse, and I know why, because there's been a 2 or 3 year build-up with the coming out of the true stationary flat Earth teaching, and we've got the attention of the whole world, and scientists are trying to explain this backward shadow, this retrogressing shadow, and they're clueless, and they're showing that they are clueless by giving very, very hocus pocus, honky shonky wonky dodgy bodgy bogus pseudoscience explanations, as they always do.
Oh, you can't make it up.
So what I believe people are going to see, if they put filters on their Zooms, etc., they're going to actually see Rahu in a way that they've never seen before for the first time in history, and they're going to be busted. Basically, they're busted. Jerry.
It's so exciting. It's so exciting.
They're done. It is exciting.
It's over.
The 21st of August will be the nail on the coffin.
What are they going to say? What can you do? Nothing. Where's the moon?
Where is it?
Where? It should be right there. It should be right there. It should be huge. It's 8,000 whatever miles, however miles wide they say. Where is it? It just disappeared.
This is it. This is what I say to people. Please get your film out and start filming before this.
Oh, yeah.
And point out where the moon is, because it's there. So where is it? Why can't you see it? It is there. It's a new moon. It's there.
Oh, yeah.
Astrology tells you that. Astrology tells you that. Common sense tells you that, because you can watch it. You can watch the full moon waning for 2 weeks. You can watch it wane, getting closer and closer to the sun in the sky, closer and closer and closer. And then when it gets really, really close, it vanishes.
Overwhelmed, overpowered by the sun.
For 2 days.
Sure.
No moon. Did it fall out of the sky?
It abandoned us.
Where is it, Globies?
Globe.
See, this is my point. If they can explain this just one thing to us.
Please explain it.
Please explain it. And then it's checkmate. If they can explain that, then they've got our attention. But they never have. They never have had the attention of truthers, real people who really, really use their intelligence and really, really think. Let's pull up an image of Venus transit, shall we? We'll do this today. What do you reckon?
Sure, absolutely. Yes, sir. Love it.
All right, here we go. Videos. Let's have a laugh. Oh. Let's see what the cult of Santa Ball had presented to Venus transit. Have a look at this. It's so embarrassing. You can tell it's a CG focus.
Pathetic. Honky shonky.
Look at that. That's pure. Look, there you go. There's.
I'm sold. I'm sold.
Is this real? Is this what they try to? No, they can't. Here's another one.
It's embarrassing. Are you sure? Is this? Oh my god. Oh my god.
There are some better ones than this. I've seen better ones. They look more real.
This is ridiculous.
No, you don't get the gig.
Oh my god.
Try this.
That one's pathetic. Sunspot. No, I'm sorry. Transit of a node.
It'll take about 6 hours and 40.
Hang on, there's a globe tart talking. Pay attention.
Oops.
Slowly across the front of the sun. It'll take about 6 hours and 40 minutes from Venus to go from one side of the sun to the other side of the sun. But not all of that will be visible depending on where you're located.
Exactly.
The amount of the transit of Venus that you get to see depends on your location. On the east coast of the United States, the sun will set with Venus still in front of the sun. So you'll get to see about 2 to 2.5 hours of the transit of Venus before the sun sets. On the west coast, you'll get to see substantially more of the transit of Venus, but the sun will still set with Venus in front of it. If you'd like to see the whole transit from beginning to end, you will have to go further west than that, out to Hawaii, for example, where the full transit from beginning to end will be visible. Transits of Venus are great to see because they're exceptionally rare. Transits occur in pairs, with the members of the pair separated by 8 years, and the pairs themselves are separated by 105.5 or 121.5 years. For this transit,
good point. So, what he's saying, so I don't know whether any of these pictures are real. I'm sure they saw something.
Right.
They would have had to seen this dot, okay, which is not Venus. It's the node of Venus, which I'll prove in a minute.
Sure. And it's just, that's why it looks so similar to the disk of Rahu.
Exactly.
Yeah.
Exactly. Good point.
Yeah.
So something's wrong here. These are CGI, man. These are not real photos. I don't know why they couldn't show real photos. I'm not doubting that they didn't see something here, because I know that people will distort what I'm saying.
Right.
They must be seeing something, because have a look at this, right? Have a look at this. You just go to Wikipedia, folks. Transit of Venus, okay? Look when it happens. Okay, the one that happened, the last transit of Venus was on the 5th and 6th of June in 2012. I remember that one. And then the one before that, 8 years earlier, was on June the 8th. Now, why the 5th and 6th and 8th of June? Well, that's Gemini, because that's where the node, I don't know whether it's a retrogressing node, like the moon's nodes. They are retrogressing 18 years in an 18-year cycle. But if it is, well, it's very, very, very slow. But I'd like to suggest that the Venus node has always been here. It's a node.
Yeah.
It's not, obviously, because if it's always here on the 5th and 6th, the middle of Gemini, that means, exactly, that means it's fixed in a certain place in a firmament. That node's.
That's right. I love it. Everything works out beautifully. The ancients know everything, and I trust them, and I don't trust NASA as far as I can throw them.
Okay, but let's read this. The first known observations and recording of a transit of Venus were made in 1639 by the English astronomers Jeremiah Horrocks and his friend and correspondent William Crabtree. The pair made their observations independently on 4th of December that year and 24th of November under the Julian calendar, then used in England. Interesting. So, guess what? December 4th is opposite June. See, that's in Sagittarius. So you see, the other node of Venus is in Sagittarius opposite Gemini.
It's beautiful. It works out beautifully.
This is all Sagittarius, man. Even if we do use the Julian calendar, which is about 11 days off, it still brings you up the middle of the 4th or the 5th of December.
Nice.
Okay, so there you go. You can see clearly, I'll get rid of this. You can see clearly that the transit of Venus, whether it's retrogressing or not, have been in those two signs, the two nodes of Venus, for at least 400 years. Here we have proof. Okay, now, Mercury. Let's have a look at Mercury's transits, guys. And I've done the wrong thing, haven't I, here? Transit of Mercury.
We'll see the same thing.
We will. We'll see when the transits of Mercury occurs, because that's not Mercury. Look at this picture here, man. That is not Mercury, that little dot there. Please, people.
Come on.
It's a CGI cartoon. Probably Danny Wilton produced this. I think Danny Wilton's working with NASA. He's definitely a NASA shill.
For sure.
And definitely upside down spinning and swine eating. Definitely. Transits of Mercury occur in May or November. Well, that's Taurus and Scorpio, another axis. Like Rahu and Ketu are exactly 180 degrees apart from each other, so the north node and south node of Mercury and Venus are directly opposite each other, folks.
It all works out.
It does.
I love it.
Let's read this. So,
science.
Transits of Mercury occur in May and November. The last 4 transits occurred on November 15th, Scorpio. May 7th, Taurus, directly opposite. November 8th, my brother's birthday, Scorpio. May 9th, Scorpio. November 11th, Scorpio. November 13th, Scorpio. Folks, these are knowns. Okay?
Yep. All matches.
You have been warned. You have been informed. You can't unlearn the truth when you discover it. Here again, look. These are CGI pics, man. Look at that dot. It's about 10 times bigger than this dot here. Look at that. You can see it.
Yeah, that's ridiculous.
There's no real pictures of these freaking transits. I don't think there are. If there are, they haven't been posted.
Where are they?
They don't exist.
They don't exist, of course not.
So let's continue with this very pleasant upside down globe chart.